Good afternoon, everyone. Tractorman 44 here. Thought I'd take a minute or two and give you an overview of a hodgepodge collection of industrial and farm equipment parts and pieces that my brother pretty much engineered and put together back in 1978 to make this old wood splitter. Kind of start off, it just obviously it's driven by a power takeoff shaft on the back of any 540 RPM tractor that has enough horsepower to turn the hydraulic pump. It's a single stage hydraulic pump, which I believe is 44 gallons a minute. It happens to be off of the Galleon road grader. We've got the bearings assembly and all these gears and chain and everything that's off of a New Holland field chopper. You can see the chain adjuster. Loosen this guy up right here and you twist that around, put a little more pressure on the block of hickory right here to put pressure on the chain, and we just blob a little grease in there every now and then whenever we grease the pillow block bearings, and that takes care of it. It's been doing its duty for, like I said, 30 some odd years. For a reservoir tank, just used a chunk of 16-inch Schedule 40 black iron pipe, and that holds about, I think we're running about right here, probably 18 gallons of hydraulic fluid. Got a hydraulic cylinder there we adapted the length of. It was off of a 4500 Ford backhoe. We adjusted the length. We cut the cylinder off itself, cut the ram off, re-welded the cylinder ends, and then welded the bosses and stuff to the end of the ram, reassembled it to shorten the stroke, because we did not need the length of the stroke that long dipper ram afforded us. Just didn't need it. The beam is an 8-inch I-beam. I don't remember the poundage per foot, but it was a heavy beam to start with. And we added a 3/8 plate to the top of the beam right there between the push block and the wedge area. And if you notice on the sides, there's gussets welded on the sides. That's 3/8 plates. And in between each one of the gussets is roughly a 6-inch by 7-inch piece of 3/8 plate steel that we welded in between the gussets. So the webbing of the I-beam is now roughly 1 1/8 inches thick. So we absolutely have no flex whatsoever. The unique thing about this is the axle. The axle is nothing more than a piece of 4-inch pipe that he kind of come up with a rudimentary A-frame adjustable axle, so to speak, by using a piece of 4-inch black iron pipe welded underneath the beam, passing the 3-inch pipe in between, and then shaping it as such so that when we attach this arm that I currently have laying on the ground up to the actual wedge, or the push block, I'm sorry, right here where my finger is, you can actually engage the cylinder and raise and lower the beam up off the ground. Shorter people like myself like to have it at a different height than taller people, obviously, so you can adjust the height of the beam to whatever height you so desire, or drop it completely down on the ground to take those rounds that are just physically too large for people to pick up and put on the beam. They get above 30, 32, 34 inch. I mean, it's just not a lot of fun picking that stuff up anymore, And so we just drop it down on the ground, bust them in manageable pieces, 2 or 3 pieces, whatever, and raise it back up and go back to work again. We really haven't had too many breakdowns. I think we literally wore the control valve out after it was about 22 years old or so. So we did have to replace this. This one actually came from Northern Hydraulics, if I remember right, and I think it cost like 65 bucks or something whenever we replaced it 16, 18 years ago or so. And one time a rank of wood fell over and knocked a fitting off the side of my tank, and that necessitated a little bit of rewelding there, and I put a replacement ball valve there just for the heck of it. But that's pretty much it in a nutshell. It does a pretty good job. One thing that I did forget to tell you, we started off with a real sharp push block. If you look back here, you can see we only have about a 6-inch push block. Okay, that's now welded to this much larger piece of 5/8 or 3/4 inch plate, which is approximately 14 inches tall, 14 inches tall. And we started off with this original small wedge, only about 6 inches tall and very narrow. We quickly realized that thinness of that wedge was not busting the wood quick enough, so my brother just raised it up a little bit. You can see how we developed this in stages over the years, but he added this chunk here on top to make it about 8 inches tall, and then put this angle iron on the back to kind of give the wedge a little bit of a flare, and it busted a whole lot better. And that was still being used whenever the push block was only 6 inches tall. So finally one day he decided, let's just go for broke, and went ahead and extended it all the way up to this elevation here, and put this much larger push block in place. And that's really been the cat's meow. It's worked really, really well. We really, really like the way it functions. And at the same time, I think he made that last modification. He added these quarter-inch steel wings on the side. That really comes in handy too for rolling wood around, up on the beam, instead of having to deal with that little old, 6-inch flange. Obviously, we have really used this thing to split a ton of wood over the years, and this right now is currently being powered by one of my favorite small tractors. It's a Massey Harris Model 30, which is about a 1951 or 1952 little Continental 4-cylinder, 162 cubic inch flathead engine. Does a real good job. It's very economical on the fuel. And I run it just when I'm working by myself at a flash idle. I do not pull the throttle back. I do not run 540 RPM simply because I just don't need it whenever I'm working by myself. When my son or my son-in-law or my brother's here, we'll go ahead and crank her back a little bit and give it to Dickens, but most of the time working by myself, I absolutely do not need it. You can tell by looking in the background that we do consume a considerable amount of wood. We've got 3 households and 3 workshops that we heat out of this. Each of these 3 sections contain, when full, roughly 13 cards of wood in each of the 3 sections. And I'm just about done with the pole wood. Pole wood piles getting really, really small. Of course, that's just the limbs and stuff, the branches off the trees. And I usually bring those home in whatever length we can carry, and then cut that with the cardwood saw or the buzz saw, if you would. And we got a few more logs to kind of dice up here, and got to get them ready to split. I've been splitting a little bit today, so you can see the remnants of what I got started with. And then here's the nasty wood over here to burn out in the shed. It's not very good at all, but it's still usable. There's heat in it, just isn't exceptionally good. And then way back in the back, you can still see a much larger pile of logs back there. But at any rate, that's the whole thing in a nutshell. Hope you enjoyed the description. Hopefully I did the old machine justice. It served us quite well for a great number of years, and I actually kind of like it. All right, we'll see you guys later. Tractor Man 44, we're gone.